So this is more about Espeland Energy and blades. Victor here is the senior blade repair technician. So he knows more about blades and operations.
It's interesting, such a good technology, good engineering, because these are big things. Those blades, they are huge, and the speed at the end is so fast, and it's getting eroded. It's getting hammered by the weather all the time. So what happens is they kind of fall apart, or not falling apart, but gradually they're getting decayed or degraded. And so they need maintenance. And it's quite a new concept, because when they started, the industry started in 1980s. People didn't even think, the engineers didn't think that they will need such intense maintenance. So the turbine wasn't even designed in a way that you can gain access easily, or you can rig rope access, or any platform to do this. So, but then the practical situation did teach them that we do need these kind of things. And for time being, it was a bit messy. All different companies did different trainings, and then after a while they realized it's not good. So GW, Danish organization, stepped in to standardize the training, and then came up with the GW standard for blade repair as well. So not just the health and safety focused trainings, but this one, where we do have a very serious part of health and safety, but it's a trade, of course. So how to repair these blades. This is how a blade looks like when it's in operation. It's not sterile, but it still kind of looks intact, and it's good for a couple of years. And then you have all sorts of issues. Yeah, and it's getting quite bad if it's not getting looked after. So this is what I'm talking about, they're getting really worn out. The paint and the filler on it, and also the glass fiber underneath. So, and also deep internal cracks getting formed. And if it's not getting looked after, then you can even lose parts of a blade or the whole blade. It's quite serious.
What about like wind resistance? I can see like when it starts to sort of cracking up a bit, would that diminish the production?
The problem with it that once you realize it in a production, you will see something wrong. Usually it's very late for maintenance. You can still do maintenance, but the price will be like sky high. Everything is repairable. If the blade is missing, you can build up on a turbine, but it always comes to the cost. You know, you don't want a highly trained, skilled team spending 1.5 years on the blade. So obviously you need to intervene with this in time, and it's a good question, because you have to carry out a blade repair or maintenance before you actually realize it on the production. And it's a bit tricky, because of course everybody is profit focused in the industry, and they want to have profit. And if the turbine is spinning good, production, why would we intervene? And that's why it's very good to get the actual turbine owners or the operators understood the principle of it, and then they can make a more sort of sensible and cheaper decision. Because the cheap thing is to keep it running, instead of wait 2 more years and then it's going to be a mission, and of course very expensive. And even this GW training, so the candidates from this GW trainings, then they're not going to be able to help them, because this is just an introductory training course. It's super intense. It's 2 weeks of solid knowledge. But even this is just an entry-level training course, and it only allows you to do surface repairs, basically, not structural.
Okay.
But even this is very intense one. So yeah, and then you have all sort of things, cracks, all kind of bad things appear. And of course we have lightning strikes. If you think about the engineering of this, it's so interesting. You have the aeroplane wings, which is of course, they go a bit faster. They go like 300 kilometers an hour, but like 10 years, 20 years. Aeroplane wings, way shorter period of time, they go super fast. But the thing is, they can avoid things. These blades can't. When the storm's coming, the hail's coming, or whatever Mother Nature throws at them, they just have to withstand. And yeah, you have issues. And then imagine lightning. This is just a glass fiber structure. If it's getting eroded, of course it's porous, so the water gets in there. Now if lightning hits it, that water will turn into steam straight away. So it will literally blow off pieces or the whole thing, or it will really speed up the process of just issues. So yeah, that's why we need to do something about it.
probably the same when it freezes, isn't it? Like
Yes.
water gets
Yeah.
in and it freezes.
Freezing also a problem, yeah, and also when you're freezing, you have ice built up, then you have deviation from the aerodynamic profile. It's usually between 2 millimeter and 5 millimeter is the sort of consensus in the industry. That's acceptable deviation from the aerodynamic profile. But yeah, ice is there, and of course it messes up the cracks, and it's just a mess. And you definitely don't want water in your blade, because that also, if it's only one blade damaged, then there's access to water, like water goes in, then the whole weight will be off as well. I mean, the blades have to be the same weight. The tolerance talking about like 10 kilos. This big, massive, huge. So it's not, doesn't take long to have that difference. And if the weight is off, the whole bearing inside the hub will be suffering badly. And so for many reasons, the lighting reasons, the weighting issues, and the speed of a deterioration does support the sort of the idea of a regular maintenance and staying on top of the conditions of blades. Yeah, so that's it in a nutshell.
All right.
Yeah.
That's good.
Thank you.
Thank you, Victor.
Yeah. Thank you very much.